All right, so I'm Rajiv. I work at Hugging Face. I spend a lot of my time talking to enterprise data science, machine learning teams about what's going on in machine learning and large language models. And so, this talk here comes out of those conversations. I should add, if you'd like to get a hold of me, just like Noel, I am also on LinkedIn and TikTok. So feel free to kind of reach out to me. Also Instagram and YouTube to a lesser extent. I don't mind questions during the presentation. I know we want to kind of keep them at the end, but if it makes sense to break in there and need some clarity, that's okay as well. So a lot of this comes out of these conversations where, starting 2 or 3 months ago, a lot of these leaders in these enterprises were getting calls from their executives saying, we've seen ChatGPT, right? Where's our ChatGPT inside the company? And so this is my thinking through this about, where are we at today? What's the current state of NLP in the enterprise? If we want to work with these large language models, and today I'm going to use the word large language models. There's a precise definition, but you can think of these as the ChatGPT or the GPT-3, and we'll talk about some other variations as we go through. But what I want to do is talk about what's the effect this is going to have on the existing workload of NLP cases, but also some new opportunities to do new things that I think some of the discussion earlier has touched upon some of that. And I'll leave with kind of some concrete recommendations for what people can start doing right away to start taking advantage of this. If we think about kind of what are all the projects that are going on within an enterprise, a lot of the enterprises I talk to, the majority of work is in the tabular domain, right? The forecasting they're doing, the churn predictions. These are all kind of from databases in traditional tabular. Now, there is a fraction of those use cases that are NLP, and then there's a smaller of other sets in here. You can think of audio and image. And this is my experience across lots of enterprises. Every enterprise is, of course, different. But if we start wanting to think about, how are these language models going to affect, these use cases, right? The obvious one is how's it going to affect the existing NLP use cases there are, right? Because language models can do these NLP tasks. And as soon as we start digging in there, kind of one of the things I wanted to do is figure out, like, what exactly are the NLP use cases inside an enterprise? So Hugging Face, of course, has lots of documentation on how to solve NLP problems. So I did a little Google Analytics and took a look at those results and found out that, most of the people were coming to learn about text classification, some summarization, question answering. These were the top use cases. Hugging Face also has a way to deploy models. And so I kind of took a peek at some of the deployment stats because I wanted to also get a sense of what are the models people are already putting into production. And again, you see text classification, embeddings. We've talked a little bit, I heard some earlier pieces about vector search and doing that. Text generation, token classification, question answering, summarization. All of these were smaller. Text classification ended up being about half the use cases. And then these other ones kind of in each of their proportions tick up the rest of that piece. So now that we have an idea of what are we currently doing in the NLP space, I went and said, let's look at what are the strengths of large language models, and let's compare them to what we have with with traditional NLP models, and we can start to gauge the differences. Now, one area is doing kind of a financial sentiment analysis. And now here, I'll just actually take a second to kind of just show you exactly how somebody would do this using ChatGPT. So one question that often comes up for financial entities is you get different statements that come out, news headlines, and we want to be able to predict what the effect that this is going to have on a specific stock. And I've seen a number of different financial companies kind of have ones like this, where these sentiments are not, is it happy or sad, but it's more based around their knowledge of what's likely going to happen based on something. And we can ask something like, in this case, the DaVinci 3, the GPT 3.5 model, or is it 3? model exactly what the sentiment is. And you can see here, I asked it what the financial sentiment is, and it gives me back an answer. Or I can go ahead and add in my other one. Already cheated and I know the answer here, which is actually, in this case, is the wrong answer. And we'll see, give it a second here to give out. It says this is a neutral one, which is actually incorrect. And so this is one of the cases that I wanted to highlight, is that we can use large language models to do some of these domain-specific use cases, such as financial sentiment. But when we actually look at the numbers, we see that if you instead use a specialty model, in this case, a Finbert model that's been trained on finance, that understands that market, for example, has different meanings in the financial context versus going to the supermarket, or the word bond, for example, has a meaning for finance people versus kind of a chemical bond or marriage bond. And for all those reasons, these specialized models, such as a Finbert model, do better for this type of text classification. And you can see it's a pretty sizable improvement over just a general purpose GPT-3 model. Now, if we switch gears and we switch to something, oh, there's my demo. If we switch gears to something that isn't so specific, that's just asking overall sentiment, the gap here closes a bit. We can see the models do a little bit better, but still taking the time to build a fine-tuned model, right? I think we had the discussion earlier, sometimes that smaller model can do better like that. But there are cases, especially when we stick with that general domain, things like news summarization, where kind of, as Noel mentioned earlier, right? GPT-3, it's sucked in news, it's sucked in web from all over, millions of different sites. And so it does a pretty good job of being able to give back that general type of information. And some of the studies that have come out around news summarization find that, GPT-3 is very close to human level. It can even beat those fine-tuning models that are out there. Now, if we ask it across other NLP tasks here, this is where we see a difference, where we see those finely tuned models still have the edge in performance versus kind of a zero-shot approach to using these models. And so this is from a recent paper where you can see in question answering, summarization, and a huge gap when we talk about doing things like named entity recognition versus those fine-tuned models. So this helps us start to get a sense of like where we're going to use these models. Now, one of the things that we can do, and this is I think we can talk about the technical details of this, but one of the fascinating phenomena of large language models is as they get bigger, as they get larger, researchers have noticed that they actually change in the degree of skills and tasks that they can do, that there's an emergence of this new behavior, something that's called in-context learning. It's often called few-shot learning as well. But what we can do is if we give the model a few examples, we can then use that to make predictions. And this is very different than traditional data science, where we give the computer some models, some machine learning, but then it retrains, it changes its bits and bytes to that. In this case, this is just purely on the inference side, where in this case, for example, I tell it the instructions, right? Like, what do I want to do? I want some to, classify its topics, and I give it some labels. And then I give it kind of two examples of how I'd like that done. And then I ask it to solve the third example. So this is few-shot learning. The thing is, with these large language models, it works great. It works. It's a really useful way to be able to do a variety of flexible tasks using these large language models. And if we look at the results of the models here, if we look at something like GPT-3, in these domains where we can use these few-shot examples, we can get performance that's near or at above kind of fine-tuned models again. So, one other example is I saw this just the other day with Stitch Fix, kind of put up a post, and this is a little bit different than fine-tuned, where you gave the examples, or okay, excuse me. This is different than the previous one where we fine-tuned and gave it examples in the prompt, but sorry, I keep saying this. Okay. too many words. So this was the few shot where we give it examples. The other thing we could do is what's called fine tuning, where we give it several hundred instructions and we actually train the model and kind of change a little bit of the model itself to get closer to this. And they found that by doing this fine tuning process, that they were able to get new descriptions that were actually rated higher than human descriptions. And I think this is why we all know this. We've all played with ChatGPT. We know how well it can kind of write language like that. So I think, when we start taking this all in for kind of thinking about these language models, the way I like to think about it is, if you're a machine learning engineer, if you're a data scientist, you're going to want to use the best possible thing, right? You're using in the realm of photography, you're going to use the fancy Canon camera, right? The 18,000 megapixel camera, because that's the best tool that's out there, and you want to use the best tool for the job. In contrast, the way I like to think about kind of these large language models is they're very general purpose. I think we had the earlier talk about kind of all the different ways we can use them as APIs. And for me, that's a convenient mental model, that these large language models are very general, while fine tuning is a very specific way with very specialized models to get to performance. But as we think through this, I also want us to remember that there's just not one large language model. There are many different large language models that are out there. And if we take a look here, I'm going to, again, divert a little bit and just show you a little bit of this, because I think a lot of times we focus on ChatGPT and OpenAI, but if we look at the landscape, and I'll put these links into my presentation that I'll upload at the end. Alan Thompson maintains a spreadsheet of all the different large language models that are out there. And you can see there's quite a few large language models out there. So I think we had some discussions about what's going to happen. How is it going to get commoditized? Of course, there's very different licensing requirements on these, right? Some of these are just as a service. Some of these you can get all the way, the bits, the full weights, and do whatever you want with them. The other thing is I think we were playing around with this, where we were kind of asking us to tell jokes. So this is a playground that I think is it Nathan Friedman, if I get the old CEO, founder of GitHub, put together. One of the nice things you can do on this playground is I can give it a prompt here. So I'm going to ask it to kind of tell me a joke. But when I do this, I can actually get this across multiple different large language models. And so I think this is one thing I want to make sure you all understand, is that there's a lot of different options here. You can see we have Claude out here, right, making a joke about bike stands. We have the Google's Flan 2, which is a purely open source model, making its, right, a man on the hat. You have Cohere, which is another kind of service out there, right, making a joke, OpenAI as well. And if you go to the playground, this is a lot of fun to play around with. I don't know how long it'll stay here, because right now you're able to do these queries for free, but you'll see there are at least 20 plus different models out here for you to be able to try. And I think this is where that universe is going for these large language models, is there's going to be an enormous variety of large language models for us to be able to use, depending on what we're trying to do. Okay. All right. So I think, taking all this in, if we have something that's very domain specific, where it's the type of information that already isn't inside these large language models, and I think there was somebody was pointing out earlier, you can do fine tuning of these large language models, but it's hard to add in additional information that isn't in there in a very cohesive way. And when you have those different domains, switching over and using some type of fine tuning with a smaller model or another dedicated language model that's been trained on that task is going to win out over a general purpose large language model. The other thing is some of these services cost a lot of money. Some of the compute requirements are quite intensive, even if you have an open source one, right? Some of the inference ones, where if all you're trying to do is summarization, right? If all you're trying to do is sentiment, maybe it makes sense to just have a dedicated model that can deal with that at the inference speeds that you want, at the scale that you want there. And so I think that's another place where we're going to continue to see kind of the existing things in large language models do that. But I think for a lot of tasks, especially if you're somebody that can understand how to use some of the techniques like few shot learning, you're going to be able to get pretty close to kind of traditional NLP. And so this is my back of the envelope kind of flowchart for thinking about this, where, as we think about NLP use cases, if they're below some threshold, and I put 100K, but everybody's, enterprise teams are going to vary on, what their threshold is for working on something. But engaging a data science team takes a ton of time, right? Somebody has to go and learn the domain. You have to build out your data sets. You're doing your testing, your fine tuning. And so there's a lot of resources that go into it. And so there's going to be what I feel like is a broad set of use cases, which are lower value, that just makes sense to have folks kind of use large language models to solve them. Now, you'll see I've used some words in here like educated, because I think that's an important element of this as well, that we'll talk about. All right. Okay, so here's my little pie diagram here showing the large language models fitting in and how they're going to fit in inside that. Yes, they're going to have an impact, but if you're looking at the load of an enterprise data science team over the next year or two, it's going to be a fairly small impact for how that's going to be. Now, so far I've given you, right, this kind of data science leader, kind of very top level perspective. And then Rashomon, which is, right, a classic film of being able to see things in different perspective. Let's try to take a look at the same problem that we've been talking about, but let's look at it from a little bit of a different perspective of kind of what the users are doing and how they're using this, because I think that also opens up some thoughts here. Right, we've seen the stats, right? We know, everybody here knows how well this has taken off like that. And I see a lot of enthusiasm. I follow a lot of the different medias, right? Whether it's the Twitter, LinkedIn, or TikTok, and people talking about this. And there's a huge undercurrent of, look at these cool things I've been able to do. Like, look at this new way I've been able to hack together a workflow using a bunch of different tools to solve a problem. And I don't know if all of you have seen it, but it makes sense to kind of re-show. This is like one of the GPT-3 kind of videos that I don't know, this is probably a year old or so, but it just shows you kind of how you could use GPT-3. And it's just a reminder of how you could prompt it, for example, to take a messy address and say, hey, give me the zip code of the address, or give me the state, and how somebody could just clean up data this way. And I can tell you, I am seeing that, like, these use cases are coming across my desk where we have teams that have built out workflows for cleaning messy data using GPT-3, and now they're asking the data engineers and data scientists, right, can you productionize this? Or, hey, we don't want to use OpenAI to solve this problem. But folks are out there kind of being able to use this like this. And, for me, I think it's amazing that we can use these tools to solve so many problems like this. And if we look at we're so early in this, right? There's people just now starting to kind of take a look and trying to understand this, where if we look at the productivity benefits, which I think most of us just anecdotally know of lots of stories of where people have been able to use this successfully to save a lot of time. We're starting to see the first wave of kind of studies around this that help us understand, what is the impact going to be on people in terms of efficiency and productivity like that. Now, one of the things we see is that people love to use this as a search engine, right? Nobody likes to Google something up, go through the 10 links, right? You have to go to the second page because it's all advertisements, right? Click on 5 links, integrate in and synthesize in the whole story in your head yourself. Like that's a lot of work. This ability to just ask it what something is and get a coherent answer, I think is something that's really reinvigorating search like that. And I think this is a really an interesting area to investigate. And what I want to show you is kind of there's a number of different ways people are being able to use these large language models to do this. So here is an example of a demo that one of my coworkers just put together, like literally, like ugh, he put it together literally like I saw it on Slack an hour before this. Let's see. Um, let's try a query here. So this is I don't I don't know if I don't know how I'm supposed to do this. Otherwise, I have another one I can show you as well. What I want to see is the idea here. Okay, this has worked. So let me tell you what's going on. So what Eno has done here is he's taken all the documentation that's out there on Hugging Face on transformers. He's taken all of that, created embeddings, put it inside, a vector database. I don't know whether he used Chroma or Pinecone or whatever. And then what we're going to do is we're going to use those classic information retrieval techniques. So when I ask it a question, like how do I install transformers, it goes out, gets those sources of information. And I can see here, if I look over here in the sources here, I don't know if I can zoom in or not. You can see over here, I have these sources here where I'm able to link, and you can see the URLs changing in the bottom. I don't know if you can see that or not, but he's linked the sources here for this query that I can get. And what's happened is the sources have been passed over to an open source large language model, in this case, FLAN UL2 from Google. And then that is used to kind of create the final response. So that way, the final text that comes back to us, install transformers with the following command, is very readable like that. So this is a fun example. I'll put the link in. The example I was going to show you, if that wasn't running, was DeepSet has another example of this type of search, where what they do is, again, use the classic information retrieval, where I'm going to ask it why the sky is blue. It goes out to Wikipedia, pulls out all the different relevant information, but then it uses, in this case, it uses a long form question answer model to then integrate all those different sources of information together into a nice kind of human readable paragraph like that. And I think, right, everybody likes this. I see U.com, Bing, everybody is putting together tools like this along the way. And I think this is a great use of combining very kind of classic information retrieval methods, because we don't want that issue of the hallucinations of how, when you use these models, they get the facts wrong. As well. So there's a lot of different ways you could do it. I think GPT Index is one of the ones that's kind of newer in this area, that's just that's just focused on building the stuff out. Give me a sec here. If we look over at LangChain, there's a lot of demos with LangChain as well to build this type of out. And I see this as a very popular way of doing it. The other thing, and we talked a little about earlier then, and I think it's worth spending a little more time, is where these large language models, we can use them as decision makers, where they're helping us make decisions that connect to other APIs and services. And I'm going to go through another demo, if that's okay. We doing okay on time here? Yes. So let's see if I can get this effectively running. So this is the Wolfram demo. And what we're going to do is we're going to first ask it a question. And I'm going to just make it a little bit more complicated, because I'm not going to say 2 to the third, because you might know that. But I'm going to ask it, what is 2.314 to the 30th power? So kind of asking, in this case, GPT-3, kind of a very mathy question. Now, you'll see when we do that, it gives us an answer. And that could be right. So let's just double check this we'll ask Google here. 2.34, and we can see when we ask Google here, it says it's like something like 8.52 to whatever, right? That which is a very different number than what we get here. And this is a classic example of how these models will give us, and often sometimes with very much confidence, but give us the wrong answer. And math is just an easy way for me to demonstrate this, but this applies in many other domains. If you ask it information on buying a new car and what are the features on cars, for example. But there's a way we can fix this. What we can do is I'm going to connect it to another tool, a math tool here, and I'll have it also show the reasoning. And so now if I go and ask it the same question here, let's ask it this. We'll see it goes through a little bit of a different process. So, and let me try to zoom in so we can make sure everybody can read that. In this case, what happens is ChatGPT first asks, once it sees the query, like, hey, is this a query that I need to use a tool for? Oh, I should use the math tool to solve this. And so we go and we use the math tool to get the right answer for that, and then bring back the answer. This is a great, this website's a great demo because there's a couple of other services that are hooked up as well. For example, a weather service as well. So you can see the difference between having ChatGPT make up the weather versus actually going and connecting to a weather service. But the key here is the agent is taking a look at the query that I give and deciding, does it make sense that, is there a tool that I have that I can use to help solve this? And if so, let me go out and get that tool to do it. And for me, I mean, this is just kind of the mind-blowing thing of this. I've done kind of several videos and TikToks on this because it's really kind of impressive to me. Here's in the text over here is another example of this where it kind of pairs a search with using a calculator as well. All right, I'm doing okay on time. This has been extended to other diverse systems. So one of the things is Microsoft has put out a ChatGPT for robotics, where literally people are controlling like drones, and in this case, like a little hand robot, by giving it instructions in natural language. And then they're using that natural language, but then with ChatGPT and other APIs, connecting that all together to be able to do and control robots doing with just natural language. Okay, so let's kind of sum this up here. So I think, some of my takeaways are enterprises really need to start building knowledge of using large language models. I think it's important for enterprise data science team to start building those prompting skills inside their own team, kind of using the tools like LangChain, because these models, these capabilities are going to be around for the rest of us. It's also important to start educating the rest of the organization on how to use these, because what I see happening, and it's already happening, is these tools allow a huge level of productivity. They allow us to do a lot of tasks very easily. And people are going to start doing that. You're going to have, the scrappy people inside the organization that want to get something done, right? The college kid who's been playing around with ChatGPT the last 6 months that just joined as an intern. And they're going to start building workflows and start using this to solve problems. So the quicker everybody recognizes that, let's make sure we educate them on what's possible, right? There's issues with sending the data to some of these services. There's issues with hallucination. What are the limitations? When should we be using them? When should we have a human in the loop? A lot of questions like that need education on these. I think it's also useful for the data science and organizations to start understanding, like, where are the pain points? Like, where are people needing to do this? Because if it's, again, it's such an important pain point, maybe it makes sense to build a full-blown data science solution for that. The other piece is we really need to start preparing for a landscape of having multiple large language models. For a long time, I see lots of demos, lots of examples, really tightly focused on prompts for just using GPT-3. And I think it's going to change our thinking a little bit when we have to start going across lots of different models. And I mean, I can see it already in kind of the development of LangChain and how we've had to kind of create new templates just this last week to recognize that people are going to use different language models, and language models you might have to communicate and interact with them differently. as well. And right, there's going to be versions of this. It's going to be a whole thing like that. But starting to think about that culture as well. I also think this is a great time to prioritize those search-related projects. ChatGPT again has highlighted, all the limitations there are of search inside enterprises, all the different silos, all the specialized information. I mean, it's a great way to start thinking about, hey, how can we use some of these tools, some of these new vector databases, using that with information retrieval systems to do that, right? And this is where if you have that prompt engineer out there, right, they can start working on connecting and starting to build these search engines, these new ways to search across the enterprise, across multiple different domains that before might have been very siloed, very separate places. We can start putting them together. And the last point, and I think that's interesting, and we need to start looking out, because I think the impact here is not going to be in the next 6 months, but over the next 2 or 3 years, as we start using these large language models, and we improve the ability for them to connect to other services and API, it's going to allow us to have natural language as the foundation for connecting to other services. And so here within an enterprise, you have lots of other tools, lots of other systems, lots of other analytics that have been built up. Being able to use language to connect all of those together to give people, not necessarily like a personal assistant, ability to start using all the information inside an enterprise through natural language and just bringing down that barrier, for me, is going to be super exciting for doing all this stuff.